when studying a possible reaction mechanism, it's important to identify the intermediates and catalysts. I think we've talked about intermediates before. In 5.4, we learned that an intermediate is a species that's neither a reaction or a product in the overall equation, but it's formed and then consumed during the reaction sequence. So usually you will notice that an intermediate is first found in the sequence as a product in one step, and then it's used as a reactant in the following step. So eventually they cross each other out. We talked about in 5.1 about catalysts, of how they can increase the rate of reaction without being used up. The way that you identify a catalyst is technically also an intermediate, but they're first found as a reactant in a step and then later as a product. So they will also cancel out like an intermediate, but the first place that you see them is in a different way. So the important thing to remember about intermediates and catalysts is that they do not appear in the final balance equation for the reaction. They have been canceled out throughout the mechanism. So we are going to see the intermediate versus the catalyst in our example 10. And that's why I don't have another one for you, is what I'm assuming. Where we will see where they come up. Okay, so we have this picture. This particle model will show a representation of a proposed two-step mechanism for the destruction of ozone in the upper atmosphere. Based on the models, which represents a species that acts as a catalyst, and what is the balance equation for this reaction? So let us write out the step equations. So this has not been given for us, so let's do that from the models, okay? So the empty circle stands for chlorine, and the filled in circles stand for oxygen. So what are the reactants in step 1? Cl plus O3. Okay, and then that turns into, what are the products for step 1? O2 and ClO. Yep, if you put OCl, it's really not that big a deal, or ClO, either one is fine. Okay, so that is the reaction for step 1. Now let's look at and figure out the reaction for step 2. So we have the ClO plus, and that would be O3, turns into Cl and 2 O2s. Okay. So now we're going to be able to identify what the catalyst is if we can figure out what the overall reaction is. So that's how I did it first, is I did the overall reaction. I did not leave myself any space. Okay, so for the overall reaction, this is going to be my overall up here. I'm going to cancel out these two. What can we cancel out? The ClOs can cancel, and the Cls can cancel. Okay, so everything that's left over, we have 2 O3s turning into 3 O2s. So the O3 is ozone, if you didn't know that, and O2 is oxygen gas. So the destruction of ozone, our overall equation, we're breaking down the ozone into oxygen gas. Okay.
Wait, will you explain why the Cl's a catalyst again?
Oh, I haven't even said that yet. Good job. Why is Cl a catalyst? Yeah, so our two intermediates, the two intermediates would be, your options for the catalyst are either the Cl or the ClO. Those are intermediates because they are not in the overall reaction. But the catalyst that, from the intermediates, the catalyst would be just the Cl, because the definition of the catalyst is that it, bless you, is used as a reactant first, but then is later formed as a product, so then it can keep catalyzing, it can keep the reaction going. So the way that you identify the catalyst from the steps, it shows up as a reactant first, but then gets crossed out. And then everybody understands how to do the overall reaction?
Yeah.
Everybody knows how to do that before this section?
Yeah.
Wonderful. Okay. Any other questions about this one? All right, let's do example 11.
Oh, this is like what was on the quiz. This is exactly what was on the quiz. Kind of. Yeah, is this not the quiz question? Or is it just
I don't really remember, honestly.
This
It might
is
be.
the quiz
It is. What did you guys pick?
I forget what I picked.
Wait, I don't want to say what I
I feel
picked.
like I picked B or I picked C. I feel like I put E.
Wait,
I put, or no, I mean B. Should I pick A and B or?
Oh yeah, no,
I
it
also
is
don't know what I
That's guaranteed.
Okay, here we go. Let's think about it. The experimental rate law for decomposition of nitrous oxide to nitrogen gas and oxygen gas is shown. The two proposed mechanisms are as follows. So we need to figure out which of the following could be the correct mechanism. Well, do they create the same balanced equation overall?
Yeah.
Yes. The intermediate for the first one is oxygen, so the overall would be 2 N2O makes 2 NO2 plus O2, sorry. And then this one, the N4 O2s are gone. So both of them do create the overall experimental equation, which is what we needed, but we need to figure out which one matches that rate law. They do both match it.
So it's E.
No, so here's the thing we have to think about.
Oh. You gotta give us partial credit at least.
I put either A or B.
I showed that I
It
did
says
it.
which of the
Miss
following could be a correct mechanism. So if you
If
Miss
mechanism
Al,
one
if
is
we
right.
put this work, will you give us at least partial credit?
If you show the overall stuff,
Yeah.
I might, yeah. I haven't created the answer key yet, so anything's possible. Okay, mechanism 1 with the first step is rate determining. Mechanism 2 with the second step is rate determining, as long as the first step is fast. Mechanism 2 with the second step is rate determining if the first step is fast. Now, the equilibrium, if you look, the equilibrium arrow is the back and forth arrow. So that means that not only can you turn it into products, but the products could go back into reactants. And so that's what the whole point of the fast equilibrium reaction means, is that it can quickly go back to its original reactants. And that's important, okay? So the correct answer is C.
really.
Oh,
I
yeah.
had that. That was my first.
I put E.
Wait, I don't understand.
Why isn't it A?
That was my first one, and then I went back and put B.
So-
I put C and then B because it's just as long as the first step.
I thought it was B and C, which means I put C.
Well, you
I
can't.
thought it was A and C.
You can't do it's like picking one versus the other for A and B,
Well, it's like
B and C. So you
Well,
can't.
exactly. That's why I picked D, because it says at least 2 of these are choices.
I know
B,
there's
B,
always
and
an
C.
option like that. And it's
So
never
this
that
is what I wrote down on my notes. Okay, it takes more energy to break apart a molecule than to collide two with the intermediate. So when you look at them, in one, this is a decomposition reaction. The first step is decomposition, breaking it down. So you have to break the bond that is holding the N2O together. Versus this one is a combination reaction where they're just two colliding together. And so based on our collision theory, it's going to be less work to collide two things together to create an intermediate that's really big that then could be broken apart because that's not stable, than it would be to have one molecule somehow have enough energy to break itself apart. Okay, so that's one way that mechanism 2 is better than mechanism 1.
I don't
With that,
understand.
is that not, is that like, so the next way you're gonna explain is gonna be so fast? No, I don't understand what you mean with the energy line. I don't rate.
Logan hasn't taken the quiz yet.
No!
Maybe I'll just not count this question.
Yeah!
I already have another one on there that somebody asked me about the catalyst question that I was like, Yeah, we haven't making these notes last night. Yeah, we haven't talked about it. See, everything just relates to each other. Great mechanism.
Wait, I'm really confused.
Yeah, like, I don't
Okay,
know.
so if we say with like that last explanation where so if we take C, with the second step as a rate determining step, if the first step is as fast as the equilibrium step. But it couldn't be A either because the explanations would contradict each other. Or
She's just saying mechanism 1 isn't the best one. Or
Right.
isn't it correct?
I'm just trying to show you how mechanism 1 is not the correct choice overall. Like you shouldn't pick any choices that have mechanism 1 because of the fact that it's more
But still
energy.
couldn't have happened though, so still couldn't it technically happen if like
It still could technically happen, yeah. And
You just want like the most correct.
yes. And again, all mechanisms are just predictions of what may or may not happen.
so it
They're
could have
right.
been.
E is correct.
E
You're
is
supposed to be
correct.
logical. You're supposed to be logical. Don't punch him.
E.
We did that bad on chapter